Water is very essential for existence of life on the planet Earth. It is required for irrigation of crops, power generation, industrial processes, recreation, and many other purposes in our day-to-day life. Water falling as rain on earth is available to the mankind from two sources: surface water sources and groundwater sources. Surface water sources include rivers, lakes, ponds, reservoirs, whereas groundwater sources include springs, horizontal galleries, wells, and tube wells. As only 3% of fresh available water occurs as surface water, shallow and deep wells are made to tap groundwater. Introduction of well drilling machinery such as percussion, direct rotary, reverse rotary, etc., has made possible the recovery of groundwater in large quantities and from depths up to several hundred meters. For constructing a well, a vertical hole is made with suitable drilling machinery at a hydrogeologically potential location depending upon the geological formation, depth, and expected discharge of the well. Various formation samples collected during drilling are examined for determining the characteristics of an aquifer. Sometimes geophysical well log is also obtained. Based upon lithological log and sample analysis, the well assembly is decided and lowered into the borehole. The well is developed and tested to determine the operational discharge. Well performance test is conducted to determine performance and efficiency of the well. Efficiency of the well depends on the specific capacity, which is the ratio of discharge to drawdown. Generally, operational discharge is 80% of the maximum discharge at which the well is developed or at which drawdown increases disproportionately. Selection of pump is important for efficient operation of tube well. It is based upon operational discharge, seasonal water level fluctuations, long-term decline of static water level, pumping water level, etc. Submersible pumps and turbine pumps are most commonly used. Selected pump set is installed in the well. The installation of a pump is a very important step, leading to efficient operation and maintenance of tube wells. For long life and trouble-free operation of the tube wells, care should be taken of factors such as its design discharge, pumping water level, voltage fluctuations, and regular maintenance of pump and motor. Usually wells are not subjected to periodic inspection and testing due to out of sight, out of mind attitude. Any deterioration in a well slowly develops to a critical point and then accelerates rapidly to its failure. A tube well may fail due to faults in its design, construction, operation, and maintenance. Design faults are due to short housing pipe, less screen length, and high entrance velocity, whereas construction faults include crooked well, well out of plumb, and improper graveling. Well failure may also be due to causes like decline in water level. Clogging of screen due to incrustation and corrosion. Rupture of well assembly. Rushing of sand. And deterioration in water quality. Hence, for better performance of a tube well, a routine maintenance program is very essential. Maintenance of daily record is very important for proper working of tube wells. Record of static water level, pumping rate, drawdown, operating hours, water quality analysis, specific capacities, sand content in water, and power consumption should be maintained. This data should be recorded at regular intervals of every 3 months on the same dates and also whenever the pump is removed and replaced after repairs. For routine maintenance of a well, discharge and drawdown should be measured and recorded regularly. After each pumping season, total depth of water should be measured. In case sand gets accumulated up to a point in the well where it enters into the screen, this should be bailed out and cleaned before taking measurements of static water level, specific capacities, closed-in head for pumps, wire to water efficiency of pump set, sand content of discharge after 5 minutes and 20 minutes of starting the pump, chemical and bacteriological analysis of water samples. During routine servicing and lubrication of pumping equipment, care should be taken to observe and record excessive heating of motor, excessive oil consumption, excessive vibration, sounds possibly attributed to cavitation, settlement or cracking of ground, pump pad or foundation. Excessive heating of motor is usually due to overload conditions and consumption of excessive electric energy. It may be due to poorly adjusted impeller, poor electrical connections, improper sizing of motor, improper voltage, etc. These defects should be removed for proper operation of tube wells. Excessive vibration of pump may result from reasons such as imbalance of impeller or from the pump being installed in a crooked well. Any decline in static water level may reduce the well capacity. This can be corrected by increasing the pump depth. And in some cases, by adding additional stages and using a larger motor in addition to lowering of bowls. If required, the pump size is reduced. Decline in pump discharge and head may be due to defects of pump or both well and pump. The problem in pump may be due to wear and tear, erosion or corrosion of the impeller or bowls due to improper adjustment of impeller. The problem is corrected by adjusting the impeller or by repairing the pump. The cause of problem should be made a part of permanent well record. Settlement of land surface around a well, cracking and settlement of pump pads and foundation are indicative of settlement of well structure. This may be due to excessive pumping or usually poor well design and construction. Such a well should be shut down or can be used temporarily by welding I-beams. Faulty operation of tube well includes overpumping above the level of operational discharge. This may result into lowering of pumping water level below the level of well screen, increase in entrance velocity, incrustation and sand pumpage. To use such a well, the pumping rate should be decreased or the well should be developed. However, to prevent the filling of sand, the well should not be allowed to work at higher than calculated operational discharge. If there is any decrease in specific capacity without proportionate decline in the static water level, it may be due to blockage of screen, or due to blockage of screen with accumulated sediment in the well, or both. This could be due to enlargement of slot opening by corrosion, settlement of gravel pack because of bridging, rupture in casing or screen, usually at a joint, failure of packer seal, incrustation of screen and gravel pack. Corrosion of screens is caused by the presence of hydrogen sulfide, chlorides, carbon dioxide, low pH of water, and dissolved oxygen. It could be minimized by painting of well assembly and well pipe surfaces with anti-corrosive paint or by the application of cathodic paint. Alternatively, corrosion-resistant pipes such as rigid PVC pipes, fiberglass, and stainless steel, etc. could be used. Under corrosive conditions, well screens should be preferred with large open areas and comparatively thicker pipes coupled with low rate of pumping. Encrustated screens reduce the yield and useful life of a well. It is generally due to poor quality of water. Various management steps to retard the effect of incrustation are: reduce the drawdown by lowering pumping rate, clean the well screens periodically by redeveloping the well, treat the well by applying hydrochloric acid, chlorine, sulfamic acid, etc. If a well gets refilled again with sediment, after bailing, samples should be taken from this well for examination, and expert advice should be obtained for identification of the problem and for rehabilitation of the well. Thus, timely maintenance action, properly worked out to overcome specific problems in a given locality, can improve well performance and increase well life. The nature of deterioration which occurs in a well may not be recognized until the well fails. Hence, record of well performance data should be maintained and results of subsequent tests of entire installation should be compared to determine the maintenance program of the well. Proper operation and maintenance will increase the useful life of a well.